highlighted in yellow for me, please? What's initiation mean again?
It means it starts.
Elongation means to get,
Longer.
but remember in transcription, what are we making longer?
The polypeptide chain. Protein.
What are we making longer? In transcription,
mRNA.
mRNA, but in translation, polypeptide chain. And then the last step is termination, which means to stop. But again, in transcription, it was the terminator sequence, but it'll be a little bit different here. So go ahead and read again what's highlighted in yellow, please, Jonathan, for initiation.
The initiation complex form.
So in initiation, what happened? The initiation complex, what does that mean? Go ahead and read that second bullet point for me, please, Isabella.
A large or small ribosomal subunit joined together around an mRNA molecule.
Again, a large ribosomal subunit and a what?
Small.
Ribosomal subunit come together with what sandwich in between? mRNA. Okay. Next one is elongation. Go ahead and read what's underlined for me, please. Or excuse me, highlighted in yellow. It's all.
This stage is where the amino acid. Oh my gosh. This stage is where the amino acid chain gets longer.
And then second bullet point. Go ahead and read for me, please, Savannah.
The mRNA is read one codon.
But what does codon mean? Every three
Bases.
bases. Perfect. And then go ahead and read the next bullet point for me, please. Right here, Emily.
A matching tRNA binds to the codon.
What does that mean? A matching tRNA binds to the codon. What does that mean? A matching tRNA. So for example, if right here, if this is the piece of RNA and the first three letters are AUG, what does the matching tRNA look like?
DAC.
It's G, what?
G.
Not G. Oh, Jesus. What is it?
D.
Not T, but U because we're still RNA. And then what's the next one?
A.
And the next one? C. So this tRNA molecule holds, what is this thing? An amino acid, which should be methionine. It's always methionine, every single time. Okay, because it's the start codon. One more time. What does the ribosome do? It reads, what is this?
mRNA.
mRNA and matches up the complementary bases, and as it does that, it matches up with a specific amino acid, and it just connects it, okay? And then, go ahead and read, what is the A site? Only what's underlined for me, please, Sam.
Arriving.
But what arrives? Abraham? tRNA. The next one is P site, which stands for what? Go ahead and read this sentence that's underlined for me, please, Caitlin.
Amino acids are connected by a peptide bond.
So in the A site, the tRNAs arrive. In the P site, the amino acids join together by a what? Peptide bond. And then in the E site, what happens? Nicholas. tRNA exits. The tRNA arrives in the A site, exits at the E site, and the amino acids join together in a polypeptide or a peptide bond in the P site. Does that make sense? If not, it's okay. We're about to go through it, but if you get it the first time, that's fine. Okay, great. The last step is called termination. Termination means that it's going to stop. But when does a ribosome stop making a protein or a polypeptide chain? When it reaches the
Stop codon.
stop codon. That's it. One more time. When does a ribosome stop making a polypeptide or a protein? When it reaches the stop codon. And that's exactly what that means. Okay? So, let's go ahead and actually look at the first steps of translation. So, again, what's the first step? Second step?
Elongation.
Third step.
Or termination.
In initiation, what happens?
Complex forms.
The initiation complex forms. But what does that mean?
The large and small.
We have the large ribosomal subunit right here. We have the what?
Small.
Ribosomal subunit here. And what's sandwiched in between?
mRNA.
mRNA. And what are these guys over here?
tRNA.
tRNAs because they hold a amino acids. Perfect. So that's the first step. What is the second step? The ribosome reads the codon, it matches up the corresponding letters, but instead of saying corresponding letters every time, we call them the anti-codon. One more time. The ribosome reads the what? Codon, and matches up the corresponding bases. But instead of saying corresponding bases, we can just say the anticodon. So if the codon is AUG, what should the anticodon be? Which should be which one? This one right here, met. Okay, and what is it gonna do? It's going to, what is it gonna do? Is it gonna stay within the cytoplasm?
No, it's gonna go attached to the.
What site? A, E, P, or A? P, because that's where it's reading it, okay? So it's going to connect here. Again, this is only for the first one, okay, it's a little bit different, okay? But once it arrives here, what is the ribosome gonna do? It's gonna read the next what?
Codon.
And what should be the anticodon? A, C, G, which should be which one?
System.
Cis, S, or CYS, and it's going to arrive at the what site?
ASA.
One more time. Again, guys, we're almost done. Okay, focus. So, what happens? The ribosome reads the mRNA. It matches up the codon with the, what are these letters called?
Anticodon.
Anticodon. So if this is UGC, what should the anticodon be?
ACG.
Which is this one right here. So what is this one going to do? Stay here?
No.
It's going to connect in this site, which is the
A side.
A site, because A means arrive, E means exit, P means peptide bond, okay? It's going to arrive, and then what's going to form?
Effective bond.
Peptide bond. Then it's going to move over. So one more time. Ribosome reads the mRNA and does what? Matches the
Anticodon.
codon and anticodon. Then what forms?
Effective bond.
Peptide bond, then it
Moves over.
moves over. And then, as the old empty tRNA exits, the next one's going to arrive. One more time. The tRNA, or excuse me, the ribosome reads the mRNA, matches up the codon with the
Anticodon.
anticodon. Then what's gonna form once this new tRNA arrives?
Peptide bond.
Peptide bond. Then it
Shifts.
shifts over, moves over. Then as the old one that's empty exits, the new one's going to arrive. But which one's going to arrive? If this one's GUU, what should the anticodon be?
CAA.
So which is which one? That. So one more time. As the old one exits, the new one
Alright.
arrives. Just like that. And then what's gonna happen?
Effective bond.
Peptide bond forms. Then what happens? What happens? Moves over. Then as the old empty one,
Exits.
the new one arrives. But in this case, there's only one, so it's gonna be not CGA, but what? GCU. And then what forms?
Effective bond.
And then after the peptide bond forms, then it moves over, and then as the old empty one,
Exits.
the new one
Arrives.
arrives. And then after it arrives, then what is gonna happen?
Effective bond.
Peptide bond,
And then move
then
over.
it's gonna move over, then as the old empty one,
Exits.
the new one,
Arrives.
and it's over and over and over again until it reaches a what?
Stop codon.
And the stop codon tells the ribosome to stop. So for example, just like you saw on question number 8, I think it's number 8. If there are 300 nucleotides, how many protein or how many amino acids can I get out of it? What do I gotta do to this one?
Divided by 3.
So 300 divided by 3 equals what?
100.
100 minus 1. Why am I subtracting 1?
Because there's only one layer left over?
No.
Or is it the start code?
Again, the question asked how many amino acids. All of those that are on that page 10.7, those are amino acids, except for 3 of them. because 3 of them code for a
Stop.
stop codon. A stop codon is not an amino acid, it's telling the ribosome to stop. Does that make sense? So again, if I ask you, there's a question on the review, there's a question on the quiz, there's a question on the test. It asks, how many amino acids are found in a X amount of nucleotides? First thing you do is divide by what?
3.
And then subtract by,
1.
because there's always gonna be one stop codon every single time. Does that make sense?
Yes, sir.
So, what happens to this protein, this baby protein that's made? Where does it go? Or in other words, post-translation. First off, where did this happen?
Nucleus.
Transcription happened in the nucleus, but not translation. Where does translation happen? Why the roughy R? Because that's where what are contained?
The ribosome.
Ribosomes. But where else can translation occur then? Anywhere there's a
Ribosome.
ribosome. Remember, ribosomes are either attached to the roughy R or they're just starts with an F. Free floating. One more time. Transcription happens in the nucleus. Before the RNA can leave, we put a 5' guanine cap and a poly A tail and cut out the introns and splice together the exons. Mature mRNA leaves the nucleus and then goes to a ribosome, either one that is attached to the roughy R or one that is free floating. Does that make sense? Okay. After that protein or baby protein has been produced or made, where does it go? Looking at this image, we've seen this in chapter 4. Where does this baby protein go? It goes to the Golgi. But how does it get to the Golgi?
With a vesicle.
With a vesicle. And then how, after it goes through, who are those proteins inside the Golgi to make sure that protein is perfect? Chaperones. And then after it finishes in the Golgi, where does it go?
Either D.
It either leaves or
Or stays to
stays. Either leaves or,
stays.
but if it leaves, what is that process called?
Exocytosis.
But what do we need for exocytosis? Starts with a V. Vesicles. And if it leaves or if it stays within the cell within a vesicle, then that can become a lysosome or a peroxisome or some other kind of organelle. Does that make sense? Again, it's talking about what we said before and then kind of piecing it together what we've been talking about now. Again, trying to glue those two pieces together. Okay. So, what I want you guys to go to do is turn to page 10.4 on the back. As you guys saw in the video, whenever you have a piece of DNA, again, this is DNA. When you have a piece of DNA, what are the 3 letters on DNA called again? Triplet. We need to convert it into what? mRNA. And what are the 3 letters called on mRNA? Codon. We're trying to turn it into a what?
Protein.
Protein. DNA to mRNA, what is that process called? Transcription. And then from mRNA to protein is called what? Translation. Does anyone have a sticky note this year?
Yes.
Can you give Matthew one? Because then you can just put it on sticky note and then just put it there so you don't have to actually do it. So again, just like in the video, whenever we have a sequence of DNA, what do we need to do to it? It said to put it in little
Brackets.
brackets. You can do that like this, or you can just draw a line in between. Doesn't really matter which one. Okay, but for these right here, just draw a line in between, like a little dash, to separate the 3. Okay, just to make it easier. On the exam, there's 103 questions, but the last 3 questions are this right here. Okay, it's worth 10 points. Okay, everyone almost always gets all of the points. They do mess up one part, but everyone always gets most of the points. Okay, But when you do this, this is 10 points. And so that means that this exam is actually worth 110 points. Again, this is the reason why I don't really do extra credit, because I already have extra credit built into the test, okay? And the progress report that I sent home that should be returned at your earliest convenience. Okay, because if not, then you don't get the points. Yes?
Isn't, we're just copying this, like memorizing it and writing it down?
No, I'm gonna give you a random sample of DNA, and then you have to convert it into the codons on the mRNA, and then you have to use the amino acid chart to make the amino acids.
Okay.
This is what we're practicing now. And on the quiz, I do the same thing, but for this part right here, you don't have to type anything, you just have to, it's all matching. So you can just pick out the amino acids that you want. Okay. But I'm gonna let you guys, again, you can practice, again, you're gonna do this, I want you to go through it all. But you can either use the chart on page 10.7 or you can use this one. I would advise you to use this one because this is the one you're gonna get on the test. Okay? I'm not gonna make you memorize it. I'm gonna give you this so you can do it. Okay?
Mrs. Hill, can I use the restroom?
Just pass it all the way. Or, Nicholas. And then pass it all the way.
My daughter's home is great. I don't even project today.
So I could be a tech in dermatology too.
You could be, oh, sorry.
They said we can be a tech in dermatology, like a dermatologist.
You can, but the only reason why I bring that up is just because I feel like a lot of people do want to be doctors, and if you really want to do it, then you really have to put in the work for it. But just understand that nursing is a better option in my opinion, even though I'm not a nurse. But I do think it provides more opportunity, especially for grad school. Because in grad school, there's a lot more opportunities to become nurse practitioners where you're essentially the doctor, so then you essentially become a dermatologist by yourself. So,
The more I'm like looking into it, dermatologists don't do anything. Like I want to be hands-on. And that's all like when I'm doing
which is fair. Again, that's the whole point of looking up and doing research and doing all that stuff. But I do think nursing, especially starting off as a nurse, provides you a lot more hands-on opportunities to do things with patients rather than just going in for 2 minutes and being like, hi, my name is Dr. So-and-so, and I looked at your x-rays and this is the problem, so we're gonna go ahead and give you a prescription of this and we'll see you in 2 weeks. And then done.
That is so boring.
And I tell students as well that it takes about 10 years working as a doctor, about roughly, depending on the specifics of your field, but about 10 years to start making good money. Like for example, like I made more than a doctor. Like in the first 5 to 10 years, I made more right now. Even though people say, oh, teachers don't make enough. I mean, you don't. I can always get paid more, because I do a lot. But realistically, I get paid more. And then a cardiothoracic surgeon in their 10th year of their program, no, I definitely don't, because they make like 3-4 times as much. So, but I just think people underestimate how much you have to work to be a doctor. Unless you're rich and your parents are already doctors, you have to be 10 times as better than anyone else. Especially as a woman and a person of color, you gotta be 10 times better than they are. Which is a lot of work. And it makes it seem overwhelming. And it is. But if you want to go get it. former student who she already switched. She wanted to be a doctor, and then she was like, okay, you're right, I think I just want to do nursing. Because she realized that, because I told them that if they really want to be doctors, then they need to make sure that they are in at least 2 to 3 organizations, and they need to start research, especially for them, like within the first or second semester. But if you go to UT Austin, you can get away with like 2 organizations, do research, but they do it really weird. Just because, like Fatima from last year, she was trying to do research, but they wouldn't let her because she's not in the College of Arts and Sciences. She's in the College of Health Sciences. So I don't know. They do it. UT Austin does it really weird. Next time, just raise your hand. Just let me know, because I feel like you needed help before that.
I know, but you're in a conversation.
I know, it's okay.
Well, I'm not gonna interrupt. So, I translate these, I can do that fine, and I write them here, and then I just want to do them.
So, what's the first 3?
I'll be A, T, G.
And then from there, then you can look at this chart. So just like I said in the video, A, well, you can't use T because this is RNA. So you have to use A.
Would I would still put
A.
A.
And then A, U, G, which is what? Met. So you just write met right here. Do the little dash. And do the next one. That's it.
I'm sorry.
No, you're fine. Yes, Nicholas.
Do we do number 14?
No, because those are the mutations. So yeah, that's I would just watch the video. Oh, the video that someone will do because Abigail won't be here
For what?
on Thursday.
I'll be here.
Oh, okay, so then you can watch it. Okay, so with that, let's go ahead and write the first one. So if you would go ahead and tell me, what is TAC in the mRNA codon, Christian?
AUG.
AUG. What is GTC in the mRNA codon, Soraya? CAG. The next one, Matthew?
AGU.
AGU. Wait, 1, 2, 3, 4. The next one, Jonathan?
CAA.
The next one, Isabella?
GUA.
And the next one, Itzel. So then what do I do with these? I look at the codon chart and I translate them from codons to what? Amino acids. So AUG should be translated to what, Savannah? Med. And CAG should be translated to what, Emily?
Blue.
And AGU should be translated to what, Sammy?
Which one?
AGU, the third one.
AGU.
Uh-huh.
SER.
SER. And Abraham, what is CAA? The next one. And Caitlin, what's the next one?
Bell.
And Nicholas, what's the last one? So again, just like we saw before, even though we have 18, right here, 18 codons, what do we do to find out how many amino acids are produced? Divide by, which should be minus, because we have a, and a stop codon is not an amino acid, okay? So that means there's how many? 5 amino acids that are produced. Okay. Is this what everyone else got?
Yep.
Okay, good. Any other questions? Okay. Am I good to erase this?
Yep.
Okay. So we're staying on our computers. So go ahead and open it back up if you didn't. Hopefully it won't take you till next time. But yeah, I should. It's kind of my bad. I didn't realize it. But what I want you guys to go ahead and do is to, on campus, go ahead and click on exam 3 module. And on exam 3 module, at the very end, it should say progress report email. what you're going to do, the gist of it, is you're going to write your own version of this, and you're gonna send this email to your parents, okay? If you got two, you got two. If you got one, you got one. Whoever's watching you, you send it to them, okay? If you want to put in whose ever email and lie about it, by all means, that's fine with me too. But if you fail, and I call your parents and say, we sent you an email on this date, and they say, oh, I didn't get no email. I'm like, well, your child lied. They used the wrong email. So do with that as you will, okay? Don't want to catch you in the lie, okay? You can use your own personal email, or you can use your TJC email, because I know that sometimes your TISD email does block some things, okay? So it's perfectly fine. This just needs to be done today. 10 points come from the progress report, and 5 points comes from this email. So it's an assignment, but it's essentially extra credit. So it's basically worth a quiz and a half. So again, if you haven't been doing your quizzes, or if you have more than two that, again, I exempt two, but if there's more than two that are a little bit iffy, then this is going to help you, okay? Again, it's like extra credit. Like extra credit, not extra credit, okay? But again, you're gonna pick biology for science majors 1, you're gonna put in your grade and your lab grade.
Teachers and students, pardon this announcement. This is just to let teachers know that the parent conference for today has been confirmed. So please make your way down to the conference room as soon as you have exited your students. Thank you.
And then make sure I know it says I plan to attend tutorials this Wednesday or Thursday. For some of you, again, you may feel like you don't need to attend tutorials, and that's fine. But just say, I plan to attend tutorials as needed, okay? Our test is Tuesdays, and a lot of you may be going on the trip, and you may not be back in time, okay? So just be aware of that, okay? Any specific questions before we move on? Emma.
There's a trip on Tuesday?
No, I'm talking about because our test is Tuesday, so this kind of defeats the purpose of going to tutorials on Tuesday after your test. So if you go to tutorials on Thursday, you can't, because you will be on the trip if you go on the trip. I'll still be here, but if you're not going on the trip, then I'll be here. Any specific questions? Okay. Yes. You have to click on, and then it says copy it, and just do that. Any other questions? All right, you guys can pack up, y'all can go. If you do have your progress report though, I will take it.
Thursday.
You're not gonna look over it before that?
I am on Thursday.
Oh, okay. Can you put it in the bar